Okay, so satellite motion. Anytime a satellite orbits another body, the centripetal force is being provided by force of gravity. Okay? And that means mv squared over r equals big G times mass 1 times mass 2 over r squared. And this mass over here is the orbiting mass. Okay, so we usually say mass 1 is the central mass and mass 2 is the orbiting mass. All right, so I want you guys to see if you can answer these two, right? Keeping in mind, there's a couple of tricks in these. Okay, this one's just asking for orbital speed, but look what it gives you. Height, and it gives it to you in kilometers. Where's height measured from? From the surface. Where does it need to be measured from? Right, from the center. So you're going to have to add what to that number? The radius of the Earth. Okay, but convert that to meters first. Okay, that needs to be meters. Right? And for this one here, you're looking for the orbital period. And remember, that's what we have to do that substitution for V. Right, so keep that one in mind for number 2. I'll give you guys a few minutes to try those, and then we'll walk through them together. All right, so for number 1, they tell us the orbital height. So the first thing I want to do is get the orbital radius, because that's one of the things that's in my formula, r. Okay, so my orbital radius is going to be 3.592 times 10 to the 6. Okay, that would be my actual height, okay, because I'm converting it into meters, so that's another 1,000. Sorry, 10 to the 5. Sorry, not 10 to 6, 10 to the 5. Meters plus the radius of the Earth, 6.37 times 10 to the 6. All right, so if I add those two numbers, I'm going to get my actual orbital radius here. So okay, whoops, not times. Plus. Okay, so there's my actual orbital radius, 6.7292 times 10 to the 6. Okay, so now I've got my orbital radius. Okay, what is the International Space Station orbit? Earth, so that would be one of my masses. Okay, 5.98 times 10 to the 24. Where do I get that from? It's on the back of my formula sheet under other useful constants. You're going to use a lot of the other useful constants because they're much more useful now, okay, in this unit. All right, and we're looking for its orbital speed. So this is the formula I'm going to use, okay? Mass 2 is the mass of the International Space Station. It's going to cancel, so I didn't need it anyway, right? All I have to do is solve for V. So I'm going to multiply both sides by R, and when I do that, the squared will cancel down here. The mass of the International Space Station cancels, and then I take the square root. So what I end up with is that V will equal the square root of 6.67 times 10 to the minus 11 times 5.98 times 10 to the 24, okay, divided by 6.7292 times 10 to the 6. All right, so the International Space Station is moving at 7.70 times 10. We only have 2 significant figures. What do we have there? We have 3, I think. We got 4. 7.6. No, 7.7. 7.699 times 10 to the 3 meters per second. Okay, so 7,699 meters per second. Right? Remember the other day when I was telling you it's about 8 kilometers per second? To orbit the Earth, there it is, about 8 kilometers per second. Okay, how many people have done the second one? I didn't think so. Okay, take a little time, try the second one. Remember that it is orbiting and giving you the altitude, which is measured from the surface, and it gave it to you in kilometers, so add 3 more zeros to that to get it in meters. And then add the radius of the Earth. That. Okay, so again, okay, this X-ray satellite is orbiting the Earth at an altitude of 114,593 kilometers. Right, so what I want to first do is get my actual radius. So I'll take that number, which was 114,593 with 3 more zeros, and add that to the actual radius of the Earth, 6.37 times 10 to the 6. Right? And we've got our actual radius there, 1.2 times 10 to the 368. All right, so we know our orbital radius, and I'll keep all the decimals that were in my calculator there. Okay, it's orbiting the Earth, so we know the mass of Earth is one of the givens, 5.98 times 10 to the 24. Okay, and we also know, what else? We don't know anything else. Okay, we don't know the mass of the satellite. Do we need it? Doesn't matter. Okay, all right, so we've got mv squared over r equals big G times mass of the Earth, okay, times the, boy, I'm struggling, times the mass of the satellite. Mass of the satellite also goes over here, okay, and that's over r squared. Now, I don't have v. Being asked to calculate orbital period, I have r. Right, so this is where I've got to do this. I've got to substitute that in for v. So the first thing I have to do with this formula is square it, because v is squared in the formula. Right? And then I'm just going to plug it straight in to that formula. So I'm going to have m 2 squared pi squared, okay, r squared, t squared, and that r that was originally here is mv squared over r. Okay, so now I've just substituted that formula right into there. Now, what do I need to do with these two r's? Get rid of that one, get rid of that one. Okay, I can also get rid of the mass of the satellite. It's on both sides, and I wasn't given it in the question. So I want to find the orbital period. So I'm looking for t squared. So I can't solve for t squared on the bottom, so I'm going to move it over here to the top. So t squared comes there. Okay. Then I'm going to move everything else over to this side. So what's r squared times r? R cubed. Yeah. Okay, and then I'm going to divide big G times the mass of the Earth over to this side. And then I'm going to square root it all. So the period of the orbit of this satellite will be the square root of 4 pi squared times r squared over big G times the mass of the Earth. Okay. Okay, and then we'll be using our 1.2 times 10 to the 8, sorry, cubed, okay, divided by 6.67 times 10 to the minus 11 times 5.98 times 10 to the 24. So there's a lot of typing in these questions, okay? A lot of big numbers, a lot of typing in the calculator, okay, for all of these. So we're going to have 4 pi squared 8 times 1.2 8, and that's got to be cubed. That's that big number there, divided by 6.67 e negative 11, 0.98 e 24, and then I got to square root that number. All right, so that's the orbital period of the satellite in what units? Seconds. Okay, and the reason it's in seconds is because we set force equal to force. That's newtons equal to newtons, kilogram meters per second squared, so our units for time come out to seconds. Right? Could you leave it in seconds? Yep. If the question doesn't specify what units it wants, leave it in seconds. Don't go to any extra work. Okay? Seconds is the unit for time. Right? That may seem like kind of a crazy number, but that's how many seconds it would take in order to orbit the Earth. It's 114 hours. So it's a long time. It's also a very long way away. All right, questions on how those work?
I solved it a teeny bit different. Like I solved for like velocity first, so kind of like the last question.
Right, you did it in 2 steps.
Mm-hmm.
Yeah, and that's fine, except I want you to get the hang of how to substitute because you are going to run into ones where you will have to. Yeah. But that'll work on that one. As long as you're not given period and asked to solve for R, then it won't.
This is a dumb question, but how did
I'm
you
sure it's
get
not.
it to like the squared and the cubed part? Because that part just went really fast.
How did I get this one to be cubed?
Like how did you put it like to the 4 pi squared r cubed over g?
In my calculator?
Like right there.
Okay, so
How'd you manipulate?
how did I
Yeah.
manipulate to get that? Okay, no, that's all right. I did go kind of fast. Okay, so I had m 4 pi squared times r squared over t squared times r. What this is mv squared over r.
Yeah.
Okay, and I substituted this formula here in for v. Okay, so I squared everything. So the 4 is the 2, right? Pi squared, r squared.
Right.
All right. Then, because there's an r squared on the top and an r on the bottom, that one goes away and the squared goes away.
Okay.
Okay,
So you squared
and-
the whole thing.
Right. Then when I started manipulating, I had to bring r squared over here. R squared times r is r cubed. Yeah?
Yeah. Okay.
All right, we already did that one. Okay, try this one. This one's easier than the one we just did. I want the orbital speed of a satellite orbiting the Earth at a height of 4.4 times 10 to the 5 meters above the Earth's surface. Know that on a unit exam, I will more than likely play that trick. Okay, so as soon as we see the word satellite, we automatically go to this. FC equals FG, right? In this one, they're asking for the speed, so I know I don't have to substitute. Okay, I'll be able to just find what V is. And it's above Earth, so one of my masses is the Earth. Okay, so that's my formula. My givens are Earth and what's my other given? Well, not quite radius, but the height, right? Can I get radius from that? What do I have to do? Add the Earth's radius. Okay, so my overall radius is really my only given. So that'll be 4.4 E5 plus 6.37 E6. All right, so there's my overall radius, 6.81 times 10 to the 6 meters. All right, solving for V. Mass of the satellite cancels. R comes over here and cancels. Okay, and then I square root. That'll give me V. So V will be the square root of 6.67 times 10 to the minus 11 times 5.98 times 10 to the 24, mass of Earth, okay, divided by that number we calculated, 6.81 times 10 to the 6, which is not squared because our R canceled off the square. Okay, and so that should give us 7.6 times 10 to the 3 meters per second.
It's just a general question, but when it comes to like givens and showing your givens, can you have like a free body diagram instead of like, 'cause like I have like a circle at
Yeah, that's fine.
Is that, or
Whatever.
do you have to make a list?
No, whatever way makes sense as long as they're there. Now, if you have a diagram, I'll generally take that as givens. Okay, any other questions on that? Okay. And then let's, no, it's orbital speed. I'm gonna give you one that's hard. Speed. Yeah, try that. I want you to calculate the orbital period of Mars. What does Mars orbit? The sun. Okay. So Mars is a satellite of the sun. You're looking for its orbital period. Still thinking old bell schedule. All right, so we got FC equals FG. So we got m 4 pi squared times r over t squared equals big G times mass of the sun times mass of Mars over r squared. Mass of Mars is going to cancel from both sides. Okay, we're looking for the orbital period, so that'll be t equals the square root of 4 pi squared times r cubed divided by big G times the mass of the sun. All right, when we plug in all of our numbers on that, we should get 6.0 times 10 to the 7 seconds, okay, which is the equivalent of about 1.9 years. Okay. All right, tomorrow we're going to talk about gravitational fields and probably a little bit more satellite stuff, and then that's basically it for this unit. All right, so Thursday we'll do the assignment on gravitation. I'll get that to you. You'll have the whole class to work on it. Okay, I don't even think I'll give you a quiz that day just to enable you to have more time, and then we'll go from there.